there are literally thousands of chains coming out. And what differentiates each one kind of makes different people's ears perk, I would say, in terms of like their actual novel technology. And with us specifically, sharding seems to be a huge part of what makes us us, right? Can you kind of explain for us real quick what sharding is as like a whole?
In general, sharding is the idea behind sharding is that if you have a large data set, for example, that you can break that data set into smaller chunks, and then do computation on small chunks of the data, that in the aggregate can be easily reassembled into the the aggregate data set that you want. So this comes out of, um, for example, large scale computing problems that existed in organizations like Google and Amazon and Facebook and so forth, that would have millions of users and information about those millions of users that they would want to crunch, to find out how to do ad targeting or, recommendations of different kinds and that kind of thing. And in order to do those, you couldn't just run it on one computer, because even a very large supercomputer was too slow to process all that data. And data was spread across a bunch of machines anyway. And so, the idea was, well, we'll just make an architecture for sharding this data and then processing the individual shards and then reassembling it into, a new data set that's been processed, right? So if you want to know, for example, Nikki, do any of your friends of yours have an interest in cryptocurrency? Then Facebook would run a big MapReduce style job across the social graph and look for friends of yours that have an interest in cryptocurrency. Except not just you, they do it for everybody, right? That's sort of the origin of the idea of sharding. And in the crypto space, this has been kind of adapted to the idea of taking a single large chain that's got lots of independent individual transactions and breaking it up into smaller chains that can then themselves be, guaranteed to be consistent with each other, right? Because the important property in cryptocurrencies and blockchain in general is this notion of consistency. When we achieve consistency, do we maintain it? How long does it take us to achieve it? What's the mechanism and that kind of thing? Um, it's a little bit different from sort of the original idea of sharding, where you break things up and then you reassemble them. But in some cases, that's kind of what it looks like. And that was one of the original designs for Ethereum 2.0, was basically just, let's take Ethereum 1 and shard it. And unfortunately, for a lot of platforms, in particular for, smart contracting platforms, it's very difficult. For payment platforms, it's quite a bit easier because most payments don't conflict. And so you don't end up with this situation where all shards have to resolve with all other shards anyway. But one of the reasons why smart contracts for Ethereum are now and probably forever will be on the proof of work chain is that they just couldn't come up with a sharding mechanism for them. So that, I think, is part of why our sharding technology is interesting to people, is that we started with the idea that smart contracts had to be sharded. There was no question about that. And then we sort of asked the question, well, how do we do that to the best of our ability? What kinds of features are going to be available and what kinds are going to be missing, based on the idea that we want to run smart contracts in a sharded environment natively.
I find it interesting because when I first heard about sharding, it was very much for some other chains that like necessarily aren't necessarily around anymore. But with Ethereum, I feel like a lot of people got traction with sharding because it was only 15 TPS. It's only 15 TPS. And it was very much to kind of fragment their network so they could have a higher throughput, it seemed like initially. But with us, it's not that, we're not necessarily saying we want to do this to have a higher throughput. It's more because we have specific business cases, use cases for each different shard.
Yeah, our root shard is payments only, so there won't be any smart contracts there natively, at least at the beginning. And so what we did is basically say, all right, we're gonna have this payments network, and it's gonna be fast as heck, right? We're gonna do 140,000 TPS on it, when it gets to full scale, and probably more than that in the long run, based on the bandwidth that we decide we want to make available. Um, when you start wanting to put smart contracts on it, you have to answer a lot of other kinds of questions, as you say, about the business case. Like, what kind of latency can these applications tolerate? What kind of storage do they require? Do they need more CPU, RAM, disk? Like, what's the resource? So once you assume you have a really fast payments network and you want to start putting smart contracts on or around it, right? Then you confront all these business questions, which are related to things like, how much CPU and RAM does it need? How much storage does it need? What kind of latency can the transactions tolerate in terms of making the user experience of the application what's expected? And there's a lot of variety in that when you're developing applications, right? If the application is facing the user, then application latency is a really big deal, which may mean that you want transactions on that shard to be really fast to finalize. It may not mean that, but that's typically the case. If the application is something that's doing work in the background, then you may have a much greater need for volume than for low latency, and you may design the shard differently as a result. And one of the things that we were able to do by sort of taking all of this de novo and thinking about the problem of what makes sense when you're building a shard for smart contracts, is that we got to think of, how the smart contracts work, how the consensus for that works, how the hardware is being designed, and then how the network is being constructed all at the same time. So that what we ended up with is this idea that shards are going to be different. Some shards are going to support, so for example, if you wanted a shard for high frequency trading or HFT in the DeFi context, that shard would need very low latency transactions with so very low finalization times, would need potentially large volumes of transactions so it could support large, automated market making DeFi dApps and so forth. And it may not care if the fees are expensive, right? Because, avoiding slippage and being able to get your transaction in and finalized in a time frame that allows you to take advantage of, rapid changes in prices is something that's important. And if you're making money, you may be willing to pay for it. That means that building computer infrastructure physically in a data center that's designed to do that and still maintain sufficient decentralization for the people in that DeFi shard to be happy about it, that's totally possible. Well, at the same time, you may have a shard that's just for managing like sports books for NFL and basketball and things like that. And those transactions don't need to be fast. They need to be cheap though. And there's a bunch of data you want to store, like you want to have every score from every game forever, and all of the current odds from all the different odds makers in different places. So there's all this data that has to get injected in there and be accessible to smart contracts. And so that environment might have lots of really low latency storage with only a moderate amount of CPU, but it would be distributed across many different data centers. So it wouldn't be super fast compared to the DeFi shard, but it would be, sort of much more amenable for sports betting and that kind of thing.
So I have a question, because this comes up a lot, specifically around like blockchain versus DAG. Is it easier to shard then on a DAG network than it would be a blockchain network? Or because I feel like a lot of people have questions about gaining consensus at the top, right? So you have all these different shards interacting with each other, and eventually they have to gain consensus. And a lot of people ask, how does it differ from a blockchain to a DAG chain? And does that have any?
Well, our root shard doesn't necessarily have to gain consensus with other shards. That's, I think, part of the thing that most people are trying. So with a blockchain, there are some inbuilt assumptions that make it hard for people to see that we could do things a different way, for example. So one of the things that's true about blockchain is you remember every transaction that ever happened. Like, great. When you're only doing one transaction a second, so your max throughput is something like 100,000 a day. Like, you can remember, 360,000 transactions a year. It's only a few hundred bytes or maybe a K or something. This is not a huge amount of data to talk about. When you're doing 100,000 transactions a second, there's no possible way you can remember everything forever. It's just not realistic. So at some point you have to start forgetting that things happened. And when you start talking about, well, okay, this shard's going to forget about transactions that happened more than X time in the past, well, when X changes from shard to shard, what sense does it make for those shards to form consensus with each other? It starts to be really hard to impose cross shard consistency semantics. So what we do is we require the two shards to agree on how much of the root currency is in the shard, and then the shard itself has to do consensus finding on how the currency moves around. So the main shard will know, for example, that your DeFi shard has 1 billion Silvermint coins in it. And knowing that, it won't let that shard put more than 1 billion back into the root shard at any point. But the DeFi shards participants are the ones that can find consensus on what happens to those billions within that environment. So if you have money in that shard and you care about it, those are the nodes that you have to be paying attention to, because they're sort of different from the main shard. And we call this a vault system. So basically, if you want to create a shard, you put money in the shard's vault, and then the nodes on that network can mint out that coins from the vault into the shard at parity, means it's still a Silvermint coin, or they could have a native coin if they want to do some exchange rate or something like that.
What would you say then? Because reading into a lot of different white papers, specifically like Avalanche, like they don't want validators to be able to join the same network and create their own shard. I think they want to like kind of assign roles of like where validators actually live on different shards. Like they're not going to have the ability to say like, I want to be in a DeFi shard.
Right.
They're going to just be pushed into a different shard.
Right.
Because from their point of view, what they say at least is that a bunch of different validators can come together and actually take over a network or can do some like shady stuff. How would we, with our architecture, kind of address something like that? At least the questions that might be asked in response to that.
So that's a good question. And if you are taking a single shard with a single currency, single bit, root currency on that shard, and you're trying to divide that thing up and allow people to validate on different shards, then you have to know, hey, the validators over here are doing it right, because when transactions cross, you don't want new money created essentially, or money to be accidentally destroyed. And so, yeah, if that's what you're doing, if you're taking Ethereum and trying to take one Ethereum network or one Avalanche network and make it 5 networks, but they're all mutually consistent, then you have to do it the way that Avalanche is doing it. We're not trying to do that necessarily. Our DeFi shard may have a completely different currency. So it's much more like the Federal Reserve Bank system in the sense that there's one top level currency, and then that currency can be deposited into shards, which may themselves have their own native currency or may use the root currency. But what happens within that shard is up to the validators that constitute it. So if you want to know that shard is not breaking the rules, then you have to participate in it. And it's possible. Like the thing is that with proof of work networks, you don't get transaction scalability, but you get security against people breaking the protocol rules, because you simply can't. There's no alternative. In proof of stake networks, the idea is that you're going to choose not to break the rules because it's very costly if you do. And so there are, even within a shard, right, there are going to be different parties who, monitor that shard. And if they identify that, collusion is occurring, they can construct a proof of it, and that can be reported back to the shards above it, right? So that you can say, hey, the validators on this shard are cheating, and here's proof. And that may be enough that we can do a slashing mechanism across shards, but that, to be completely frank, is still in the design stage. I think we'll get there, but I don't want to promise it.
Okay. I guess one of my last questions would be, a lot of these different networks, when they talk about sharding, they already have an idea of how many shards they want to do. Like Ethereum wants to do 64. I think Parachain has a set number. Every single one kind of has an idea of how many they want to do. Is there an idea for you in terms of like a number that you want to do, or is it more just like we're going to kind of let this play out and see how it goes?
Yeah, there's in our system there isn't any particular reason why groups other than Silvermint could form their own shards. And one good example is, suppose that you wanted a bridge between Ethereum and Silvermint where you could put Ethereum into a smart contract on the ETH network, and then you would get Silvermint out on the Silvermint network that you could then spend somewhere. That would need to be implemented as a shard. So I think any kind of like layer 2 type stuff, or applications like that, or anybody who has a specific application that they want to design may want to design a shard to go along with it and then attach it to the network. So we're going to just build tools that allow them to do that work, right? That allow them to construct a shard, specify the parameters, attach it to the network somewhere, and then when they're done, they can detach it and it can go away. And in that sense, our sharding architecture looks much more like a computer file system where you've got directories that are getting mounted in from the network or what have you. And then it does like the way that traditional sharding has been thought of in the crypto space, is dividing up a single network. Ours is a way of assembling different networks into one structure. Theirs is a way of taking one network and dividing it into different chunks of work. And I don't think that system works very well for cryptocurrency, because what you end up with, you end up with bad sharding algorithms and bad compromises, which is what Ethereum has post-merge, right? Is now they have one proof of network where the smart contracts run, and a bunch of little bitty proof of stake shards where all the payments run, and getting them to coordinate together is going to be complicated and annoying and difficult forever. Or you end up with the layer 2 thing where you have lots and lots and lots of layer 2s, but no consistent way to bridge them into the main network. And so everybody's doing their own custom bridge, which is subject to attack from hackers. And just the other day, we saw the Euler network bleed out $190 million in the matter of minutes because they had a bug in their Ethereum bridge. And we've seen, I think the biggest one we've seen is like 600 million. But bridges have problems if they're not done exactly right. And so I think by doing it one time and allowing people to use the same code, we can make sure that it's much more consistently done right. And that just makes sense to me.
I would also say, like, on top of what you're talking about right now, a lot of conversations at least come out in the wild is like, why do we need sharding when there's like ZK rollups or ZK snarks?
ZK rollups and snarks are sharding.
Yeah, exactly.
It's just a bad sharding technology. And the problem with ZK anything is that you have to remember everything forever. That's not practical in a large scale system. It just isn't. So there are some ways around that in ZK, but like zero knowledge proofs are not the answer.
But like with us specifically, I would say too that like with us, our finalization is in 20 minutes. Like some of those ZK snarks and ZK rollups, they take 10 to 20 minutes to finalize.
Right.
And like people just don't understand that.
Yeah. And even in our root shard, which is probably going to be the slowest one, finalization is 2 to 3 seconds. Whereas in an individual subshard, it could be single or low double-digit milliseconds, right? Depending upon what your application needs are. So,
can you kind of explain why low finalization is desired?
Well, nobody wants to stand in line at Starbucks for 20 minutes waiting to pay, right? So, at least in the payment space, low finalization is important because real world people have things to do besides wait around on their payment to clear. Also, like if you're a merchant, right? So for end users, like when you're buying a cup of coffee at Starbucks, your transaction finalizes in a couple of seconds. But for the merchant, actually, it finalizes for like 120 days because you can always go into your credit card statement online and you can click that Starbucks transaction and say, I didn't buy this, and dispute the transaction. And then that kicks off a process inside the credit card company that may result in the merchant having money taken away from them. And so for a merchant to have finalization go from 120 days to 2 seconds, that's a really huge reduction in risk for them in terms of their, their financial position. And it also reduces risk for the payment network, which means that the whole thing can be cheaper because there's less risk that has to be paid to deal with. That said, in DApp design, I mean, there's all kinds of reasons why low latency might be a big deal. As I said, price slippage, I think, in AMMs and other kinds of DeFi applications is a function of transaction latency, because, in the existence of mempool, which is a mempool is a result of extremely high transaction rates. So it's like a coping mechanism. But if somebody can observe your transaction coming into the network and then inject a transaction ahead of it in line that will finalize first, but at a slightly better price, then they can arbitrage your traffic, and that's no good. Nobody wants that to happen. So low finalization times will really help with that, because there's a smaller window for slippage to occur, and you can kind of get everybody on a fair basis where, especially if there are no mempools. Other examples include like games that are real time. If you have a real time game, you might not want events like being shot by another guy to take more than a couple of milliseconds. And so knowing the result of, I started shooting at him, he started shooting at me, which one happened first, kind of thing, that can be a big deal in some game environments.
So I guess my very last question is, I feel like for a long time, people have been talking about sharding architecture. No one has really gotten it right yet. And I'm going to kind of tee you up for this, but I feel like a lot of it has to do with them saying, like, halfway through their project or towards the end of their project, they're like, sharding, like, now is like what we're going to start doing. When did you and Mike decide that sharding was going to be part of this project? Because we haven't even launched, at this moment right now, we have not launched testnet, and we are talking about sharding already. So
yeah, we've been talking about sharding since 2018.
Yeah,
it was one of the original sets of tools that we put into the network, because we knew it was really obvious even back in 2018 that there were going to be a couple of major challenges for the cryptocurrency space and blockchains in general. And that one of those was going to be scaling networks so that they were fast enough in terms of finalization. But another one was going to be scaling networks in terms of total transaction throughput. And that you could move the total transaction throughput number and the latency number at the same time to a certain extent. But as I said, there's limits on how many transactions a network can process, because eventually you can't store enough, especially blockchain networks, you can't store all those transactions in your history. It's just not possible. And so we knew that to solve that and to make applications be able to have the kinds of resources that they needed, we were going to have shards that differed in the way that they treated data flows. And that was just an observation that came from having worked on lots of large scale systems at Google, where, some systems needed really large relational databases, and other systems didn't need relational databases at all. They just wanted document storage. And sometimes the document storage could be slow, and sometimes it had to be super fast, and it varied a lot. And so we started sort of with the premise that blockchain space was going to be a good way to do large scale applications that were financialized. And then ask the question, how do you build tools that are necessary for those large scale applications to work the way the developers want? And the answer included sharding. So that's why we've been thinking about it.
Thank you, Nash, for sitting down with me and explaining sharding a little bit more. And then it'll be a nice place to point people that want to know more about Silvermint sharding architecture. So
it's always
if you guys want to learn more, make sure to join our Discord or follow us on Twitter. Make sure to have the links down below. Nash will be in our Discord, so you can ask us questions if you want to ask him more things about sharding.
For sure.
So,
like and subscribe to our YouTube.
Yes.